Hey there, chemistry. This is Ms. Ruark. This is podcast 8.3, and we're going to learn how to use solutions to do stoichiometry. You guys love this so much, I know. Okay, all right, so molarity, which you just learned about, is a concentration unit. Remember, molarity is moles of solute over liters of solution. Okay, and we can use this molarity can be used as a conversion factor. Oh, conversion factor. Remember something over the other, so to do dimensional analysis. Now, dimensional analysis is what we've been doing this whole time. Okay, so let's say that I have 4.0 liters of a 0.4 molar solution. Well, that right there just means that I have 0.4 moles per 1 liter. And I can use that to figure out how many moles I have by setting it up, making sure that my units, if I have liters here, I have to have liters on bottom, and then they cancel, and that would let me solve for moles, right? 1.6 moles. Okay, so that's what we're going to do. Okay, so example 1 says, how many moles of HNO3 are in a 2.0 liter solution of 0.200 molar HNO3? Okay, so we're looking for moles. Okay, and we know that we have a volume of solution and that this right here is our molarity, and we're just looking for moles. Okay, so how would we set this up? Well, we start with this number here, 2.0 liters, and we know that this can be written as 0.200 moles per 1 liter. So we put 1 liter on bottom and 0.200 moles on top. And we solve. The liters cancel, and we're left with 2 times 0.2, which gives us 0.4 moles of HNO3. Now, some of you might have seen that, and you're like, okay, I get that, but look, Mr. Ark, you've already pointed out that you have moles, or you're looking for moles, you have volume, and you have molarity. And remember that molarity is equal to moles per liter. So this is just one way to solve it. This is using dimensional analysis. Look, here's a second way to solve it. You can do it algebraically, where you just take and plug in for your variables, right? So M here goes in for M, 0.200 M. Okay. Moles is what we're looking for, so we keep that as moles. And then liters would be 2.0 liters. Okay, how do we solve for this? Well, we multiply both sides by 2.0 liters. Okay. This cancels here. Liters times moles gives, or molarity gives you moles, so moles would be equal to 0.4 significant figures, Ms. Ruark, 0.40 moles of HNO3. And see how it gives you the same thing? So it's really not a big deal which way you do it, just as long as you pick one of them and you go with it. Okay, so we need to use all of this to help us figure out how to prepare solutions, because when we prepare solutions, we're going to have to measure out a known amount of a sample, and we can figure that out using our molarity equation like we just did. And instead of solving for just moles, we would keep going to grams, right? Okay, so there's a picture here that shows you kind of how to make a solution. So in step A right here, what we're doing is we're going to mass the solute. Or if it was a volume, we would volume the solute, but we'd mass the solute needed to make the solution. Okay? And then in step B, we would place the solid or the solute in the volumetric flask. And that's what that neat looking thing right here is. It's called a volumetric flask. And we would fill it halfway with water, or with the solvent. Okay, now I can't say just water because sometimes your solvent might be something else. Okay, so halfway with your solvent. In step C, what we're going to do is we're going to cap the flask and mix until your solute dissolves. Okay, and then in step D, we're going to uncap and fill to line with solvent. Okay, now what in the world does that mean? Well, this volumetric flask is actually calibrated so that it holds a specific amount of solution in it. If you go over the line on the flask, then you end up making your solution is too dilute. If you don't go all the way up to the line, your solution is going to be too concentrated. And you're like, whoopity-doo, Miss Ruark, it's like a couple drops of water or a couple drops of solvent. But you know what? In a specific chemical reaction, if you need a specific amount of something to react and you don't have that or you have too much, it does mess up your chemical reaction. And so that's why it's important that you know the steps. We will actually practice this, and you'll get to practice being chemist and making your own solutions. It's so much fun. Okay, so solution preparation. How do we use this to do that? So it says how many grams of HCl would be required to make 50 milliliters of a 2.7 molar solution. So here's our molarity. We're looking for grams, and we are trying to make a 50 milliliter, so that's our volume, solution. Okay, now we know that molarity is equal to moles per liter of solution. Okay, we're looking for grams, but if we solve for moles, can we get grams from there? Yeah, we sure can. Okay, and I'll show you two ways to solve this, and hopefully I won't run out of time. Okay, so one way to solve this would be is if I would start with I'm going to do the stoichiometry way, or the dimensional analysis. So I would take 50 milliliters of the solution, and I've got to have it, this right here is the same thing as 2.7 moles per 1 liter. Okay, but I can't cancel liters and milliliters, so we've got to change this to liters, and we know that 1,000 milliliters are in 1 liter. Okay, now I can set it up where my 1 liter goes on bottom because I want to get rid of that liter, and we've got 2.7 moles in that 1 liter, and that cancels. Okay, but we don't want grams of HCl. This is moles of HCl. We don't want moles, we want grams. Okay, so 1 mole of HCl is equal to 35.45 plus 1, so 36.46 grams of HCl. Okay, moles cancel, and now I'm left with grams. And when I solve it, I should get 4.9221, but I want two significant figures, so 4.9 grams of HCl. Okay, so that's one way to solve it. The other way is algebraically. So we know that we have 2.7 molarity, and I've got moles on top, and I've got liters on bottom, but this needs to be in liters, and that would be the same thing as 0.0500 liters. Okay, so 0.0500 liters. Okay, we've got to multiply both sides by that on the bottom, 500 liters, and then moles would be equal to, I don't know, let me solve for it real quick. Okay, 0.135 moles of HCl, but we want grams, so we've got to keep going. So 1 mole, and then we multiply it by 36.46 grams, and we should end up getting the same number, 4.9 grams of HCl. Okay, so it doesn't matter which way you solve it as long as you solve it and you get the right answer. Okay, so in solution stoichiometry, as you've just seen, we know that molarity times liters equals your moles. And you would use your mole ratio from your balanced chemical equation to help you calculate the amounts of substances in that. So we're just doing stoichiometry using the solutions, right? Oh, great. Okay, so it says calculate the mass of BaSO formed when excess 0.200 molar Na2SO4 solution is added to 0.5 liters of 0.5 molar BaCl solution. Okay, so just to skip the formalities, we need a balanced chemical equation. So we know that we're reacting Na2SO4 and we're reacting that with BaCl2. It is a double replacement reaction, and so Na will attach itself to the Cl, and Ba will attach itself to the SO4, 2 to 2, 1 to 1, those are your charges, and then to balance it we put a 2. You guys are versed in this, and that's why I'm going quick. Okay, so we know that we've got 0.500 liters of this that's being added to this, and they want to know what is the mass of BaSO formed when excess of this is added. Now it says excess, so guess what? Don't get confused by that. It's just saying it's an excess. Don't worry about it, right? Yes. Okay, so one of two ways you can solve it. You can do it the algebraic way or the dimensional analysis way. I'm going to do it the dimensional analysis way. If you do it the algebraic way, make sure you get the right answer. Okay, so I always start with the amount that they give me. They say that we're starting with 0.500 liters of BaCl2, so I'm going to start with that. Okay, I want liters to go away, so liters goes on bottom and moles goes on top, and this thing right here will give me moles per liter. So 0.500 moles per 1 liter. There we go. Okay, now we're at moles. So we just have to do our mole ratio. Now we're doing moles of BaCl2. So that would be 1 mole of BaCl2. And we want to know moles of BaSO4. Right? And that's a 1-to-1 ratio. Okay? That cancels there. And then they don't want moles, they want grams, so we've got to keep going one more step. Moles of BaSO4 and grams of BaSO4 here, and the mass of BaSO4 I think is 233.4. Okay. Everything's canceled out except for grams, BaSO4, and so we solve. The calculator gives us 58.35 grams, but we want 3 significant figures, 3 significant figures, 3 significant figures. Looks like we're going with 3 significant figures. So 58.4 grams of BaSO4. And that's how you do solution stoichiometry. Okay, the next one says finding the molarity of an acid. So on this one, they're talking about something being titrated. Now we haven't gotten acids and bases yet, but that's just talking about an acid-base reaction. So we've got sodium hydroxide, and that's reacting with ethanoic acid, or acetic acid, same thing, and it's going to give us NaC2H3O2 plus H2O. And look, it's all balanced already. Yay! Okay, so we know that we've got this solution and we're reacting it with this, and they want to know what's the concentration of this. Okay, well the problem is we can't start with anything with that. We need to do our concentration, we need moles over liters. Well, we've got liters, but we don't have moles, so we've got to get to moles. Well, how can we get to moles? Well, we can use this right here to get to moles. Okay, so start with your volume, 20.0 milliliters, but we can't use milliliters, we need liters. So in 1 liter, there is 1,000 milliliters. Okay, now we can go from liters to moles by using our molarity, 0.25 moles over 1 liter. Now we're at moles, but this is moles of sodium hydroxide. I'm getting lazy. I'm not writing my stuff in. I do apologize. Okay, so we know 1 mole of sodium hydroxide will give us 1 mole of the acetic acid, C2H3O2. Okay, so that will give us our moles. So now we just have to solve, right? Because we needed moles. So 20 divided by blah, 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 blah. Okay, I've got the math done. 0.005 moles of acetic acid. And we want to divide that by our liters. This is in milliliters, so we would change this to liters. 0.0232 liters. And then we just solve. And the calculator gives us 0.215517, blah, 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 blah. We only want 2 significant figures, so we're going to keep that at 0.22 molar acetic acid. And you would write HC2H3O2. Okay. I know I'm going fast. If you need to, please pause it, watch it again, and then we're going to practice when we get into class, so don't freak out. All right, last one that we're going to do. This one here is calculating the molar mass of an acid. All right, so here it says that we have this many grams of an unknown monoprotic acid. Mono means 1, product means proton, so that means it just has 1 hydrogen. So we're just going to write it like that. Okay, and we're titrating it or reacting it with NaOH. Okay, all that other fancy stuff there, you'll understand what that means when we get to acids and bases. All right, so that means that, oops, on this side we're going to have N with A, or Na with A, and we're going to have H2O. And it's a 1-to-1 ratio. Okay, I'm probably going to get cut off here. I hope I don't, but if I do, what you're going to do is just take the 22.5 milliliters, and we've got to change it from milliliters to liters. Okay, to liters, right? And then we're going to do liters and moles of the NaOH. Okay, and then do your 1 mole to 1 mole ratio, and that's going to give you moles. I'm going to get cut off here. We want molar mass, which is grams per mole. So finish this up, bring it to class with you, and we'll check your answer when you get to class.